If we're going to find angles in the real world and apply some trig, we really need to understand how a compass works. So we need to learn about headings. So you're probably familiar with the basic directions, north, south, east, and west. Hopefully, and you should be. And then there's some in-between directions. Northeast is halfway north, halfway east, 45-degree angle there. Southeast, southwest, northwest. And then if you go halfway between halfway, so about let's see, this would be a quarter of a circle, eighth of a circle, so like a 16th of a circle. So from halfway between north and northeast, we'll call it north-northeast. From halfway between northeast and east, we'll call it east-northeast. So those are kind of even more in between specific directions. So let's run through some things you need to know. So general name, using some of the terms I just talked about, what direction is 155 degrees? All right. So that compass had a little bit more detail than this one, but 155 is down here. There's southeast and there's south. So that's a combination of the two. We would say south-southeast or SSE. So because it's halfway between south and southeast, roughly, south-southeast. Okay. Now some skills you'll need to have. Let's suppose you go 50 degrees one way and then you turn around and walk back. All right, well, if you go 50 degrees one direction and you turn around and go the other way, you're going the exact opposite direction. So let's talk about some measures here you hopefully have noticed. Now, I'm going to flip back. It's got a little bit better number. The numbers are easier to read anyway. So compass starts at 0 degrees at north, and it goes clockwise 360 degrees, which is a full circle, so that should make sense. A quarter of a circle is east, that's 90 degrees. Another quarter circle would be south, that's 180. Another quarter circle is 270, and of course back to 360. So every 90 degrees, you get a named direction, north, south, east, west. All right, so if I'm going 50 degrees first, that's this way, and then I turn around and go the opposite direction, well, anywhere you are, if you go the opposite direction, you've turned around, and it's a figure of speech, you've turned to 180, you've turned the exact opposite direction. So that figure of speech has meaning. Anytime you turn around, you turn around 180 degrees. So if you want to figure out what the opposite of 50 is, then we need to take 50 and add 180. And if you add 50 and 180, you get 230. So you're walking at a 230 degree heading. And I can probably do it on here. If that's 50, 230 should be the opposite, and that seems about right. Okay. So suppose you go 189 degrees one way, and then turn and go 237. All right, so I'm going 189. Whoops. And I should probably, it's a good time to talk about this. You should really try to draw these to scale as best you can as far as the actual direction. 180 south, so 189 is something like that. 237, all right, well, 270 is west, so 237 is kind of west-southwest, sort of, that direction. So let's try to get these as close to being accurate as I can, all right? So if I ask you, how many degrees did you change your direction? Let's type in, how many degrees did you change? All you really need to do is subtract these. You were going 189, and then you turned and went 237. So whatever that difference is, that's what you changed. So 180 or 237 minus 189, it's about 48 degrees. So you changed 48 degrees. That was again the change in direction. Okay. All right, finding the heading or the angle between two headings, that's going to be a big part of what you're going to do. So let's suppose you're standing here on the ground looking up these two mountains. And something you got to make sure you do, the angles have to be pointing away from you. That's always the case. You have to think about standing, and here's kind of the way you would draw it on paper. You're standing right here. You're looking at two different peaks. You're pointing toward both. They're pointing away from you. Both angles, both vectors are pointing away from you. If that's the case, then we can draw it out like this. If one's at 94, one's at 127. All we really got to do is just subtract those two, and there's our heading, 33 degrees. That's it. Or that's the angle between them, not the heading. The angle between those two headings, 33 degrees. So if I was drawing a triangle and had to solve it, which is something you'll do eventually here, That's how you would get your angle. Now, what's tricky is when north's in between there. Same situation, but let's say this is 331 and this is 14. Well, north is kind of in between. So there's what it might look like on paper if we draw it out. Again, I'm standing here and I'm pointing in both directions. I can't point both directions. I've got to do something first. It's not going to work. We'll get to that. But if I'm standing here pointing at both mountain peaks, but north's in between, it's a little trickier. So here's a couple ways to go about it. Method one, you can split the angle. So here's my drawing from up here, but I went ahead and put north in the middle. The reason this is tricky is because the headings start over at 360. And we got to deal with that. So I like this method. I think it's pretty easy to do. If I put north in here, then I've only got to figure out one thing. And that's this angle right here, which is 29 degrees. Because 331 to 360, you subtract those, you get 29. This one I didn't label because from 0 to 14 is 14. You don't really have to do any work on this side. So once I've got those two, this angle and this angle, I need to add the two together. So I get 43 degrees. That's the angle between these two headings. Now, method two is to envision a full circle here. So I've got my two headings again, but I envision that they're sitting on a full circle, which we know is 360 degrees, which you can think about that sitting on a compass as well. And if I want to figure out the angle from here back around counterclockwise, and that's where this arrow comes in, going from 331 back around to 14, I can subtract those, and I get a 317 degree angle. You've done that in geometry, so it shouldn't be groundbreaking. Once I know that, this whole piece is 317, and I know the whole circle is 360, I can just subtract the two. Oh, whoops, wrong thing. Well, that's how I got 317. I took 331 minus 14 degrees. But once I know that, I know the full circle is 360, and I know this is 317. So whatever's left, if I subtract, it's what's left in there. So I subtract those two and I get 43 degrees. Same answer, just different way to get there. This is probably the hardest thing students struggle with year to year. So I'm talking about the angle on a path, all right? Plane flies on a heading of 264 degrees and then turns to a heading of 207. Again, get these as close to accurate as you can. What's the angle formed by the course? All right, well, 264, 270 is west, so that's pretty close to west, just a little bit to the south. Then it turns to 207. All right, well, 180 is south, so 207 is sort of at an angle. Just realize that probably looks backwards on the camera screen. But 207 is a little ways west of south. So something like this, doesn't have to be perfect. Just don't put 270 degrees pointing north. You'll mess everything up. You'll get your answer probably wrong, and it's just not a good idea. Get it in a general direction, get it close. All right, well, what's tricky about this is if I'm trying to find this angle, again, I've got to be standing at this point, the vertex, and I need to point in both directions away from me. If I can't do that, I got a problem. And that's what's going on. I got a problem. I've got to be standing at this vertex and pointing in both directions. So I need to know what heading is going the other way. This one's good. This is pointing away from me. This one's pointing toward me. That's not okay. And we know how to do this. We've already done it. If you want to find the opposite direction from 264, subtract 180 from it. Think of it this way. Oops, give away too much. Think of it this way. Here, this one's now 84 degrees because it's pointing away from it. That way, I guess, on your screen. There we go. Once these are pointing away from me, now I can just subtract them just like I usually do. 207 minus 84 is 122.